This video shows a fairly advanced setup of a HinksPix Pro along with a long-range Smart 16 SPI output, 4 SPI output, 4 SPI output, and finally a 16 AC output for legacy props. We're also going to throw in 16 SPI outputs here. All right. Now let's also see how we're going to send data to this. We're going to be using X-Lights in this example. Now you do not have to use X-Lights. Our controllers all work with every brand of sequencing software. X-Lights is just a simple solution here. All right. Now in this particular setup, we're using our Mega Tree, which each has 100 pixels per output. We're going to be distributing those over 32 strings. And we're going to use Jack 1 here for that. Now we're also going to be using Jack 2 in a daisy chain configuration, and we're going to first go here, the green line being a Cat5 cable, to the input of the first receiver, this is receiver 0, then over to this next receiver 0, 1, receiver 1, and then finally out from this one over here to this long range AC on device number 2. Now, again, we also have here 16 SPI outputs that will be putting out data locally for a matrix. All right, so let's take a look at this in X-Lights first. So in X-Lights, we have our mega tree, and it has 100 pixels. It has 16 strings, but they're folded at 2 strands per string. So that means we're going to start at the bottom, go up, go around, and come back down. This is a semi-advanced function. And we also have a matrix, 16 strings of 50 pixels each, nothing unusual. We have candy canes, each with 99 pixels running off of one receiver. And then we have 4 arches, each with 100 pixels, 50 pixels per row. And finally, we have our 16 AC channels. Now, here we've just represented the 16 outputs as dots. You would normally have these as lines or floodlights or something like that. And then they would be individually assigned. But for simplicity, we've just used one string. And for reference here, you do need to go down here to string type and change these from RGB to single node color when using an AC receiver. Okay, let's first go over here and look at our controller. Now, this video has assumed that you have already connected to your controller using the wired interface to this web page, and that will allow you to configure your controller. Also, this video does not include any really advanced topics such as more than 170 pixels per output. All of our props have less than 170, and this is a significantly easier configuration than something over that. Okay, now your display or your screen may show something different from what is shown here, and we are constantly updating our software and firmware, and this may change over time, but the same elements should still apply. Now, one thing we're going to do is we're going to use the design tab, but before we go there, we're going to click over here and go to miscellaneous settings, manage controller configurations. If you have an SD card in your controller, you can save the entire configuration. This allows you to load configurations for example, a Christmas display and then a July 4th display. Or if you wanted to create a configuration on one controller and then transfer that SD card to the other controller and load it, or send a configuration to someone else. You can see them here. And this will make sense in just a moment. We go to the design tool because we're going to save our configuration in the design tool to one of these saved configurations. All right. So first thing we're going to want to do is go again to the design tab here, and we're just going to give it a name. We're going to call it test 8. And what we have here is some information that will appear down here, and it will expand as we add in and tell the controller what our configuration is. Now, you may think that, hey, it should know. I know I have a long range and I have an SPI output, but it doesn't. And the reason it doesn't is because it doesn't assume that you're going to always use this controller. You may take that configuration to another controller. So first thing we need to do is tell it what boards we have. So each HinksPix Pro can have 3 expansion boards. So in this example, we have just 2, and they are ordered at the top here as 1 through 4, a long-range expansion, and these jacks are red, and then there's a 16 SPI. Now, if you do have your actual controller configured, you can go up here to output settings. You can see 1 through 16 in this particular configuration is set up as long range than SPI. Yours may be set up as SPIs at the bottom, long range in the middle, and then not present at the top. So take a look at your actual configuration because each controller is custom made for each customer. Okay, so we're on the design tab. We first need to tell it we have one long range board. And when we check that, you can see that it's adding some additional information here. One is long range board assignments and then Cat5 cables. So if I check the second one, you'll see that this extra box appears. And that would assume that, of course, we are doing two long range expansion boards, which we are not in this case. We're also checking off the 16 SPI board, and we'll see that that adds 16 outputs that are shown right here. All right. Now, we also need to, because there is some other options for unique circumstances, we need to tell it again what we have. And again, these need to match up. So if 1 through 16 is long range receiver, we need to tell it, hey, the long range receiver, I have one, and it is on the ports 1 through 16. Again, yours may differ. Be sure to look closely. All right. Now, we don't have anything on 33 through 48 on this particular setup. Now, we need to tell the receiver or the design tool that we are using a particular Cat5 cable for each given long range. So we're using Cat5 1 and Cat5 2. Now, this is cable 1, but it's really Jack 1, Jack 2, Jack 3, and so on. And so this goes 1, 2, 3, 4. And then if you started over again at the bottom and you had a second board, it would also be 1, 2, 3, 4. Okay, so what I'm going to do is say we have a Cat5 cable here and a Cat5 cable here and none on 3 and 4. And you can see that that 3 and 4 jack is empty. Okay, now we also need to tell it that we're actively using this. So we're using Cat1 and Cat1 and Cat2. So we go over here, Cat1, Cat2. And after we do this, if we scroll down here, you'll see that the design tool has gone ahead and added some things. We need to add a few more things. First is we see each one of these Cat5 cables. So we cable 1, cable 2. Now it needs to be told, the design tool, what's at the end of this. It doesn't know. It has no way of receiving two-way communication. It only sends data out. So it needs to be told what is at the end of these cables. And so we have to tell it that. So the first thing I'm going to do is just click this button. So we first have cable 1, a 16 SPI. And they come in here. Now, you may also notice here that they're in a weird order. If we scroll down here to the 16 SPI ports that are on the bottom of the control box or controller, we can see that it shows 1 through 16 in a sequential order. But these are out of order. And there's a good reason for this. It's because for each individual Cat5 cable coming out, there are 8 wires or 4 pairs of wires. And each pair of wires carries data. Now, normally on a 4 output, if we have 4 outputs like we have here, output 1, the data comes down the pair of wires, the first pair, and it goes to 1. And then pair of wires number 1 is transferred over here, and then the data on output 1 is also output here. We just tell the receiver, hey, you start looking at the data at this point in the stream, and you start looking at the data at this point in the stream. So this means that each of the outputs, one in here and one in here, are all linked together. They're actually receiving the same data. But on a 16 long range, what we have is really just 4 of these 4s. This is why the address count is shorter than 16. So there are 4 long-range receivers built into one board logically. So when we add that, what we see here is that this is the first pair of wires, 1, 5, 9, 13. So the data coming down the pair of wires, the first pair is going to go to 1, then 5, then 9, then 13, and the second pair, 2, 6, 10, and 14. That just explains why that's appearing that way. Now, on our second Cat5 cable, we do have Jack 2, and we need to put in 2 4s for long-range smart receivers, and then a 16 AC. So we'll just do that, 4. Then we add another 4. Then I go over here, smart AC 16, and I add that. And you'll notice it has a board ID. Now, the board ID is a unique number for each board. Each board in the string needs to be told what it is. Now, in this one, it's only one receiver connected up to one Cat5 cable, and we're just going to start at 0, which is the default. So they're numbered 0 through 15, or total of 16 possibilities. And then the next one is going to be 0 here, 1, and then 2. And if you're wondering where to set those, they're the little red switches here, 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 and up here. And there's also a little chart off to the side of each one, usually, that will tell you how to set the switches. It will also tell you in the controller up or down, but it's also listed there. So we do need to go in here and just change this second one to 1. So we have 0, 1, and 2. So again, this is going to be 0, 1, 2. All right. We now have told the design tool what we physically have connected. We have told the design tool, hey, everything here is all connected. These are all the cables coming out of all these receivers. Now we need to tell it what's connected to those cables. And again, as I mentioned before, you must know what is going to be connected to each one of these outputs. So designing your display is the first step before configuring it. And in this case, we have 100 pixels per output, 199, and 16 ACs. So let's go ahead and tell it what we have. So there's only one string here, and we need more of those. So we need to add some more string. I'm going to click that a couple of times. And so the first thing we're going to configure is this 100 pixels per output. So we're just going to go up here, and I'm just going to say mega tree output 1. And I'm going to go over here, and you'll notice it skipped past total channel count. You're not entering this information. You are entering information in these 3 sections, or these 4 sections here. And it is in the nomenclature of universe, then the channel. So it is important to understand that what we're going to be sending is DMX data, a DMX universe, and there are up to 65,000 possible on each controller. What we're going to do is send channels down that universe. A universe is comprised of up to 512 channels. So if we just pull up our little calculator here and we take 512 and we divide it by 3. Now why 3? Because each pixel, if we're talking about pixels typically, requires 3 channels: red, green, blue. So if we do that, we see we have 170 with a divisor, or remainder. Well, as I said in this example, we're not using more than 170 pixels per output. It is possible to put more than 170 pixels on a single output. And the most that you can put on there is 170 times 4, 680 on a given output. Now there's other limitations here. If you're doing super high counts and you're doing more than 170 pixels or something high like that, you may need some additional information. See other videos for the information. But our setup is moderately complex. So the first thing I'm going to do is I'm just going to give it a universe number. Now we could start anywhere, 101, 1. I'm just going to start at 1. I'm going to put 1, and then how many channels? Well, where are outputs? How many pixels do we have? We have 100 pixels, so 100 pixels is 300 channels. 300 channels control 100 pixels. So I put 300 here. And now I need to then just put this remaining data down here. Now what I'll do is I'm going to skip past this and we'll do this at the end of the video. So I'm going to also go down here and we're going to be putting output 1 through 16. So we'll have mega tree output, output 16, and we'll also have 16 and 300. And let's now configure the next thing in our list. So the next thing in our list here is going to be 100 pixels per output on this receiver for the arches. So I'll just put in here arch 1, and I'll go over here and I'll put 17 is the next number, and it also has 100, so it's going to be 300 channels. And we're going to put arch 2, arch 3, arch 4, and then we're going to go candy cane 1. Oops. 1, and then so it's going to be 17, 18, 19, 20, 21. And this has 99 pixels. So we simply bring our calculator down. 99 times 3 is 297 DMX channels. 297. And this would be candy cane 2, 3, 4, and then finally AC lights. And if we have 21, 22, 23, 24, and it's going to be 25. And we are going to put in here 18. Now, long range AC is a little unusual because it's an older design of technology, and there's only one channel for each output. It's not three channels for each individual pixel. And so for each cable hooked up to here is going to be a universe. So I'm sorry, a channel within a universe. So our universe is going to be 25. So this whole receiver is going to be 25 universe, and it's going to be cable 1. It's going to actually be channel 4. I'm pretty sure. Let me just double check that in a moment. And we are going to use, let's see here, 16 times 3. Oh, I'm sorry, 16. So if we take 16, it's going to be 18. So 18 divided by 3 is 6 pixels worth of data. So it's still going to send down 6 pixels data. So we're going to actually put in 18 here. So the 18th channel will actually be output 16. And we'll come back to that later. Now, I'm going to go ahead and complete the setup. And when I return here through the magic of editing, you'll see all that complete. All right, I'm back, and I have also added in the matrix. And you can see here, we just start at the top, mega tree for long range, long range, long range, AC lights, and then our matrix. And I just put in 150 channels because we have 50 pixels each. Okay, now at this point, we're just going to do a check. I'm going to click this. It says sanity check. And then up here it says string data is valid. We're good to go. Now, if this number were something outside of a norm, you're going to see some error. You'll also see that it put in the channel counts here. How many channels in each one of these. Now, if there was an error, for example, I put in here 900 and we did a sanity check, it'll see here it says string index. Now, string index refers to this number right here and this index number right here. So if you're looking for where your error is, it's on that line that says it up here. It says string index 1, channel 2, or grouping 2, has an outs of range number. Now it's 900, and it can only be 512 because this is a universe, this is a universe, this is a universe, and this is a universe. This would assume that you're rolling over universes. And again, this is not for this particular display in our configuration. So again, check it. Everything's good. Great. Now we're on our way. Now all we need to do is tell the controller, hey, each of these outputs needs to be put somewhere. So we need to tell it, hey, I've got these outputs and I want to link them in to these particular receivers. So I'm just taking my display as I've designed it, right, with all my pixels here. And I now need to tell it those 100 pixels with that universe, and it's going to be on this particular megatree, for example. And I'm going to go ahead and show a few examples of this. And then what I'll do is, through the magic of video editing, come back in with a completed setup. So the first thing I need to do is I need to go down here to the physical port. So this is physical port. I'm just going to click on here. So this data from up here is going to be transferred down to here, but I have to link them. So I click here, the box turns green. I need to go up and tell it where Megatree output 1 is. So I'm going to go up there, click that, and you'll see that it added it here. I'm now going to go to 2 and click on 2. And then I'm going to go to 3 and click on 3. And you can see that they're mapping out. Now, also down here, we have our arches. So I'm going to go up here and just click on my arch, for example. Right there, you can see my arch and my candy cane here. And that's candy cane and our smart AC. I'm going to go up here to the AC lights, and there it is. And then finally down to my SPI ports for my local outputs, these right here. I'm going to map those right here to my matrix. 1 and 2. You're going to hear a beep each time that happens. And I'm going to go ahead and complete this and be right back. All right, we've now mapped them all out by clicking on each individual area and then mapping that string. And we can see that our matrix strings 1 through 16 are mapped. AC lights, candy cane, arches, and the megatree outputs. Now again, this is long range smart 16, and I have, for my simplicity, just mapped them 1, 5, and so on, so that even though the physical ports are out of order, I've put them in the same order so that logically they'll work. Now, what we need to do is do one more check. So we did a sanity check here on our strings. Now we're going to perform a check on the entire design. I'm going to go up here, click this perform a design check, and it says design checks okay. Now, if you had an error, it would show up here. Maybe you've mapped too many pixels to a given output. There is a limit on the number of pixels. And if you were to have done that, that would appear here. Now in this particular case, we're all okay. So I'm going to go ahead and say save design and save it to the SD card. And I'm going to click OK. And it's been saved. And what I'm going to do is this has not yet been configured. So if we go over here, all of our outputs have yet to be configured. This is just some defaults. So I'm going to go over here, manage controller configurations. I'm going to select our test 8, and I'm going to install that configuration onto the controller. And we can see that it has been installed, and we need to reset. Now, one quick note that receivers need to get their configuration and told what they're going to do. So you want to, before we reset this controller, first go make sure that all of the switches are set properly on all these receivers if you have them hooked up and you're going to be testing them. Additionally, we recommend powering them all down, powering them all up, so that when they boot up the first time, they will receive their configuration data. So I'm going to go ahead, go to the Reset tab, and I'm going to hit Reset, and in just a moment, it will reboot. All right, our controller is now rebooted, and what we can do is just kind of a cursory check to make sure everything went okay. So the first thing we're going to do is we're going to look at our output settings. So we're going to look at our long-range receiver ports, and we see this is stream 1, 2, 3, 4. So this is jack 1, jack 2, and you can see 3 and 4. Nothing connected down here to 3 and 4. We see a smart 4, a smart 4, and a smart 16. That's in jack 2. This is a smart 16. You can ignore this smart 4 because, again, these really are just 4 output long-range receivers all linked together internally. And we can also see that they're ordered the same, 1, 5, 9, 13, and so on. Okay, and so it knows the pixel counts. So if we just look, we're going to see that the start channel, so this is controller start channel 1, controller end channel. So what we're doing is we're mapping internal channels. Now this should not be confused at all for anything that's a controller channel as DMX or anything in an application like X-Lights. These are totally for internal use, and we'll show you on the next tab. Now we'll also see that this goes to 4800, 4801, and then it ends at 7206. And you can see our next one should be 7207. So now let's go to our next bank here, our board, and 7207 and through 9606. So everything is looking good. We got 50 pixels on all those outputs for that matrix right here. And if we come over here to the E131 tab, this is where you have our universes. Just FYI, if you're having any problems with your pixels, make sure to set this pixel speed from 800 to a lower number like 700. And it has already configured everything else. See, we see 41 universes, just like we had. We can see the channel count. So this right here, all the way through 26, is the matrix. We have here, we have, let's see here, I forget, the output, I believe, on the, let's see here. No, here's the AC. These are our Oh, these are our interleaved universes. So you're going to see here that the universe number is not consistent all the way through. It's done some adjustments. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 through 17, and we're getting a little out of order here. Okay, so what I would recommend doing is taking a screenshot of this data so that you're looking at it on your screen, a piece of paper, whatever, because we're going to use that information to create our setup in Xlights. Now, how the data is flowing from Xlights into the controller through the E131 data DMX universes into the outputs. So it's actually going here, then to here, to the actual outputs. Okay, so let's go ahead and pull up our Xlights and start configuring it. Now, I've already got my props in here, but I need a middle layer because in here, between Xlights, we have to have controller configuration and then the prop. So at the very end of this long sequence of events, we have sequences, then we have props, then we have controllers, then we have E131 configuration in the controller here, then we have outputs, and then we have the actual data going to these devices. Okay, so let's cool up our Xlights here and start configuring. So the tab I'm going to go to is controllers here, and I'm just going to go in here and say add Ethernet. I'm going to go up here and put a name, HinksPix, and you can, change that as you see fit. You do not have to do this. Um, and you might see these in upload input, upload output. We do not recommend using those generally. I'm going to be showing a manual method of configuration. If you're familiar with those options and understand the ramifications of that, great. Be aware that that information may overwrite data in your controller. Okay, so I've put in my IP address of the controller, and I'm going to tell it how many universes. So let's flip back over to our universes here. And you can see that we have 41 total universes to work with. So let's go ahead and go back to our Xlights here. And what we're going to do is enter universe count 41. And it's going to ask us how many channels per universe. I'm and I should also note here, there are many ways to configure Xlights. Some people may tell you put all 512 channels, 510. I use the literal method, and so we're actually going to enter in here a number of 300. That's how many channels it's going to default, and that'll just save me some time at entering data. Now, I need to tell it what actually is on each one of those. So I'm going to say individual sizes by checking this box. And over here on the left-hand side, even though it says sizes, this is actually the DMX universe. So this is where your channels in your design really come into play here. So let's go to our design and select test 8, and just for reference here. So we've got all these outputs. So if you want to take a screenshot of that, you can then have all those channels. So let's go ahead and put them in. So my first universes 1 through 16 are 300 channels because they're for the mega tree and it has 100 pixels per output. So you can see that by default, it's already set that. So 1 through 16 universes, we already have that. So now let's go back, look at our HinksPix. So the next one, 17, is also 300, 18, 19, 20, 300. Okay, we're good to go there. And then we get down here to candy canes. So universes 21, universes 21 through 24 are going to be 297. Oops. And so we're going to go back in here. And oops, I have already forgotten that number. All right. Oops. So that's going to be 21 through 24. 21 through 24. 297. 297. 297, 297. Okay, so let's see what we've got here on universe 25. On universe 25, we've got 18 channels. And then after that, we've got 150. So universe 25 is 18. So we're going to go over here. Universe 25 is going to be 18. And then finally, these are all going to be 150. 150. I wonder if we can copy and paste these. I'm just double clicking in these things to make them highlight. And so we're just telling this X-Lights how many DMX channels of data are on each universe. And this will make sense in just a moment where we start to line up all of those props and tell it which universes they are connected on. Okay, now I'm going to go ahead and click over here, save, right? Okay, now I'm going to go to the layout. Now we need to map what we've done here over to the actual props. So let's start with a mega tree, and its universes 1 through 16. So let's go ahead and go to the mega tree, and it will be 1 through 16. So I'm going to go to the mega tree here, start channel, click on that. I'm going to click on these three little dots here. I'm going to say universe, and this is the IP address of the controller. You can just say any if you don't have any kind of overlapping universes, which I never recommend. And we're just going to say 1 because where does it start? It starts at 1. So if we look back here, it starts at 1. X-Lights already knows that we have 100 pixels per output. So we click OK, and guess what? Here we see that it says, hey, I've used the pound sign being the universe number, pound 1, channel 1, through pound 16, universe 16, channel 300. That's 4,800 channels. And of course, that is right. That maps up perfectly to 16 and 300. All right, so the next thing we need to do is map up 17 through 20 for our arches here. So we're going to go up to our arches, and I'm going to say set channel, and that starts at 17. So I'm going to go ahead and select 17. Now, there's some tricks here you can use. You can do what's called chaining, and you can see that it says it starts right here at 17, and then after 17, it then links up the next one and the next one and the next one. For simplicity, you could leave it that way. I prefer being absolute so we know exactly what we're looking at. So I'm going to take the little bit of extra effort here, and I'm just going to directly map each one. Sometimes this can make troubleshooting a bit easier when you're down the road. Okay, so 17, 18, 19, and finally 20. 20 here. And you'll notice in these drop downs here, you notice how it says exactly 41? So it's just got what we have available from the controllers tab. All right, next on our list here is our candy canes. These start at 21 through 24. So let's go 21 through 24. So candy cane 1, again, same thing. 21 universe, 21. And I'm not going to chain them. See how you get these errors, like it's trying to link to the back of the mega tree? Again, if you can, we do recommend going ahead and linking that to a very specific universe just to prevent weird stuff from happening. Okay, so we were on, let's take a look here. We were on 21, so now we do 22. 22. And Candy Cane 3 is going to be 23. Well, I guess that works out well. You can see that it actually has already done some of that. It's trying to link them up because it knows Candy Cane won the 2 before it. But again, I'm going to be literal, and it's going to be 23. And finally 24. See how it's also trying to do that? And finally 24. All right. And the last thing we have on our list here is our matrix. And our matrix is going to start here on universe 26. 26. So let's just go up here. Universe, any, 26. Click OK. And you can see that it has 41 as the ending number for the universe. And what do you know? We have 41 channel 150 channels. Okay, so at this point, Xlights is fully linked up. We can save it. You can go up here, File, Save Layout, and you're all set. You can see that we have all of our channels linked up. Oh, that's not true. We forgot some. We did not link up our AC. So let's go back and look at that. And if we look here, we can see that is Universe 25. 25. So we're going to go up here to 25. And we're going to have to do something a little special here. So we're going to select this, and it's going to be Universe 25. So let's go back and take a look at what we've done here in the setup. So we set up 18 channels. Why? Because the controller has 16. That doesn't seem right. So 18 minus 16 leaves 2 extras. So this is because the controller, the controller, HinksPix controller, sends data down the wire, and it always goes as groups of 3 in the pixels. So what it's doing is it's leaving out the first 2 channels, and it's filling out the remaining channels. So we actually need to skip the first channels that we're using. So of this universe, we have 18 channels. They would normally start with 1, 2, 3, all the way to 18. And we're shifting over by 2. So it's just a shift over by 2. So what does that mean? It means when we go in here, we need to not change this or set this to the default of 1. We actually need to set it to the start channel of 3. So we're going to skip the first 2. So 3 is actually output 1, 4 is output 2, and 18 channel is output 16. So we click save. Okay, now we're done. Now, you want to make sure all this works. Now, one of the quick ways to do that is first test things in the controller. Now, you could skip to the sequencing application, but we always try to do everything when we're doing testing and we're not sure where a problem is. We do that at the most lowest layer in the system, and that would normally be at the controller layer. So we could go up here and test that here. So we could go to test outputs. This means that the controller will be sending data to the lights, and we can simply just say, turn all ports on and blink them white, for example. And all of your long range on all of these outputs should now be blinking. And if they're not, that would indicate we have something wrong. Receiver set up wrong, receiver didn't restart or receive it to configuration, the address on the receiver was wrong, the pixels or something is not set up correctly, and we need to test those. So that would be a way to test for that. And then, of course, you can test the SPI outputs also. Now, if all those tests work fine in the controller, great. That means that our controller must be set up right, at least in terms of turning on and off the lights. So then we would move up to testing in Xlights. Don't skip to trying to do a sequence at this point. Do baby steps and make a test at first. So go up to Tools, Test, and you can test in 2 major groups, 3 technically, but usually you use outputs or models. And so you'll see that all the universes are listed here. So here's our main controller, and you can see all of the universes. So this is universe 1 in the little brackets and channels 1 through 300. Now, this number off to the right is the internal channel number of Xlight, so you can ignore that. So these are the DMX channels in the brackets, and the curly signs are the DMX universes. And you can go in here and turn them on. But you're probably wanting to turn them on by the model. Now, there may be cases where each of these is useful. So if you have something mapped incorrectly, you can go in here and say, oh, I think universe 30, DMX channels 1 through 150 should be, and we could go up here to this design, load our design, and we think universe 30, when you turn it on, should be output 5 on the matrix, right? So you can turn those on that way. You can also go over here to the models. So here we may want to test arch 1. We check it off, we go over to background, and you'd move this slider up to background intensity. You also need to make sure that this output to lights is checked off. And you can also do some advanced testing like red, green, blue, white, red, green, blue, white, red, green, blue, white, black or off. And this allows you to test at a per prop basis. So you could text your arch 1, and when you check this off, and this is turned on, and the speed's sufficiently high enough, you should be able to see arch 1 come on. In this case, it should be red, green, blue, white, red, green, blue, white. And if it's not arch 1, we need to back up and backtrack and figure out where that problem is. And when we check this off, all of the pixels on the matrix should now be lit up and turning red, green, blue, white. So this concludes the complete setup of a moderately advanced HinksPix configuration using this setup. Of course, if you have any questions, contact us at support@holidaycoro.com.